Today we're going to do a dynamics tutorial over acceleration in terms of distance to velocity in terms of distance graphs. We're going to use A as acceleration, S for distance, and V for velocity. The basic equation we're going to use is A is equal to V dV over ds. And we're going to use that in the form of A ds is equal to V dV. This equation comes from the standard equations, which is V is equal to ds over dt, and A is equal to dV over dt. You solve for dt and set them equal to each other, then integrate, and that's how we got this equation. Let's start off with an example. We have an acceleration versus distance graph. The vertical A is your acceleration, the horizontal S is your distance, and we have an object moving at 6 meters per second, and it's accelerating at 6 meters per second out to 1,000 meters. At that point, the object then decelerates at -4 meters per second to an unknown distance s prime, where it comes to complete stop. Now, this one's fairly simple. We already know our acceleration out to 1,000, so our acceleration is 6, so we're going to plug that in for A. ds is equal to V dV. We're going to integrate both sides, and so we have 6s is equal to 1/2 V squared. V squared is then equal to 12s, and V is equal to the square root of 12s. Now, what this will do is give us the first curve on our velocity in terms of distance graph. Now, we need to know the maximum velocity that it reaches. It's going to reach its maximum velocity at 1,000 meters because that is when it starts to decelerate. So we're going to plug in 1,000 for s, and V is equal to the square root of 12 times 1,000. So V is equal to 109.54 meters per second. Now we're going to do the exact same thing, but for deceleration. So our deceleration is -4 meters per second squared. So we're going to plug that in. -4 ds is equal to V dV. Integrate both sides. -4s is equal to 1/2 V squared. V is then equal to square root of -8s. This will give us the curve on the VS graph for the deceleration, starting at 1,000 meters. Now, we need to know what S prime is. Since the acceleration is constant and is not, changing over the distance, we can use our constant acceleration equations. So let's go back to constant acceleration equations. V squared is equal to V naught squared plus 2 AC S naught minus S. S is going to be the same thing as S prime. So let's plug in what we know. V is equal to, our V is 0. Our V naught, we're starting at 1,000 meters. At 1,000 meters, we are going 109.54 meters per second. And we're going to take that plus 2 times our deceleration of -4 times S naught, 1,000, because we're starting at the peak velocity, trying to find out where S prime is, minus S prime. S prime is then equal to 2,499.89. We're going to round that to 2,500 meters. Now we have all the information needed to create our VS graph. So our vertical is going to be our velocity, our horizontal is going to be our distance. We know that we are looking at 2 points, our point of velocity at 1,000 meters and at 2,500 meters. And our maximum velocity is 109 meters per second. So our first curve is going to be the square root of 12s, which is going to start at 0 and go up to 109 meters. 109 meters per second at 1,000 meters. Then we're going to drop down at a rate of V is equal to the square root of -8s, the second equation we found, and that curve is going to look something like this, and we're going to drop down to a velocity of 0 again at our 2,500 meter mark. This is how you take acceleration in terms of distance to velocity in terms of distance and make a graph. Alright, now that we have done acceleration in terms of distance to velocity in terms of distance, we are going to do the reverse. We're going to do velocity in terms of distance to acceleration in terms of distance. So again, V is velocity, S is distance, A is acceleration. We're going to use the same equation we used in the first one, which is A is equal to dV over ds times V. Now let's look at a problem. We have a graph, and on that velocity versus distance graph, v is equal to 0.1 s plus 10. So this is going to be the velocity of an object, and it's going to go and it's going to continue out to 500, and we're going to say it reaches a velocity of 60. Now our acceleration is equal to dv. We'll just put in the velocity equation first. So we have a is equal to 0.1 s plus 10. Now let's take the derivative d of 0.1 s plus 10 over ds. So we're taking the derivative of v in terms of s for the second part of that equation. Now when you take the derivative, s is our only s term, so we end up with a 0.1 being our derivative of v. So our acceleration is equal to 0.1 s plus 10 times 0.1 times 0.1 through. You get 0.001 s plus 1. Now we can take that and put it in an acceleration versus distance graph. So we know that we accelerate all the way out to 500. So a is equal to 0.001 times 500, and that will give us our acceleration at 500 feet, meters, whatever this happens to be, plus 1. A is equal to 1.5 meters per second. And that is how you take velocity in terms of distance and change it into acceleration in terms of distance graphs.